Hello, this is Mr. Molo for lesson 7-1, integer exponents. So these are how all the videos are going to pretty much go. I'm just going to go through the lesson that we go through in class. This way, if you want to rewatch it at home, you can. So this first slide is always going to be up. Just something to do when you walk into the classroom. I won't go through it in videos, but since it's the first video, I'll go kind of slow and explain what each of the slides are. Then we'll talk about what the plan is for today. So we're starting chapter 7, section 1, integer exponents. Our objectives are to evaluate expressions containing 0 and integer exponents, and to simplify expressions containing 0 and integer exponents. Okay, so just a review from last year. So if we're looking at exponents here, like 5 to the 5th power is 3,125, 5 to the 4th power is 625, 5 to the 3rd power is 125, and so on and so on. So when we're kind of filling in the rest of these, it makes sense that 5 to the 0 power, some of you are going to want to say is 0, but it's not, because you can see from the trend that 3125 divided by 5 is 625. 625 divided by 5 is 125, and so on and so on. So 5 divided by 5 is 1. And now 5 to the negative first power, some of you would want to say is negative 5. It's not, because if we keep with the trend, 1 divided by 5 then is 1/5. Okay, 5 to the negative second, again, keep dividing by 5, so 1/5 divided by 5 is 1/25. Okay, so there's kind of two ways to look at it, where we can keep following the trend, or 5 squared is 25, 5 to the negative 2 is 1 over 25. So it's really just 1 over whatever that is. Okay, so going back, so that's the base. The x would be our base, the 4 would be our exponent. Okay, so a 0 exponent, any non-zero number raised to the 0 power is 1. So no matter what the number is, if it's to the 0 power, it's going to be 1. So some examples here, 3 to the 0 power is still 1. 123 to the 0 power is 1. All of these numbers to the 0 power is 1. A negative exponent, a non-zero number raised to the negative exponent, is equal to 1 divided by that number raised to the positive exponent. So like I just said, 3 to the 2nd power is 9. So 3 to the negative 2nd power is 1 over 9. 2 to the 4th power is 16. So 2 to the negative 4th power is 1 over 16. Okay, so for simplifying this, we just said this. 2 to the negative 4th power is 1 over 16. 5 to the negative 3rd, well, what's 5 to the 3rd power? That's 125. So 5 to the negative 3rd power is 1 over 125. Okay, we'll skip some of these and get to some more complex stuff. So something like this, pretty much the same thing, just making sure that you understand when it says, kind of a two-part. So p to the negative 3rd power when p is 4. So that means 4 raised to the negative 3rd power. Well, 4 to the 2nd power is 16. 4 to the 3rd power is 64. So 4 to the 3rd power is 64. 4 to the negative 3rd power is 1 over 64. Okay, some more problems like that just get a little more complex with depending on what you're adding. And then we get into some of these that have some negative exponents here. So we'll see a problem like this. Pretty much the rule of thumb is if it has a negative exponent, it's going to switch from the top of the top or the bottom. Okay, so if I have a problem like this one here, so a to the 0 power times b to the negative 2nd is the same as c to the negative 3rd power or d to the 6. Okay, so a to the 0 power I'm just going to say is 1 because I know that it's going to be 1. B to the negative 2nd power is really the same as 1 over b to the 2nd power. So it's going to go down. It was on the top, it was on the numerator part, now it's on the denominator part. Okay, c to the negative 3rd power, it is in the denominator. It's going to go up to the numerator part and become positive. So in your final answer, you really shouldn't have anything positive there. So now a to the 0 becomes 1, b to the negative 2nd goes down to the bottom, c to the negative third goes up to the top. d to the 6 can stay on the bottom. It is positive, so we don't have to put it on the top. It's not going to switch sides from the denominator to the numerator, so we should be good. Okay, looking at this one down here, so g to the 4th power over h to the negative 6. Again, g to the 4th power can stay where it is because it's already positive. It doesn't need to switch sides, so we're just going to keep it as g to the 4th power. H to the negative 6th power, since it's negative and it's on the bottom, we're going to switch sides, so it's going to go from the bottom to the top. So then it's going to become h to the 6th power. And then you could put this all over 1. Doesn't matter. Let's see if we can find one more example. Okay, so here's one that kind of the work's already done through for us, so I'll just talk through it. So I have 2r to the 0 power. Remember, anything to the 0 power is 1. So I'm going to replace that r to the 0 power with a 1. There it is in blue. Okay, so 2 times 1 is 2. M to the negative 3rd power. So let's make this in a fraction. Maybe that's easier to see. It is on top. It's on the numerator part of the fraction. It's going to switch down to go to the denominator part. And we'll see that right here. So now 2 times 1 is 2. That's where this 2 comes from. And to the negative 3rd power switches sides, goes from the top down to the bottom. So the m to the 3rd is on the bottom. So this is going to be our final answer right here. Okay, same thing here. R to the negative 3rd power. Well, that negative 3 can't be there, so it's going to switch sides, so it's going to go down to the bottom. 7 is fine staying down there, so it'll stay down there. So it's 7 times r to the 3rd power on the bottom. You need to have something on top. You just can't have a fraction with a 0 on top. So the 1 goes to the top. This one looks like the one we just did. G to the 4th power divided by h to the negative 6. G to the 4th power is fine staying on the numerator, but that h to the negative 6 needs to switch sides, so it's going to come up to the top. So g to the 4th power times h to the 6. And remember, we can put this over 1. Doesn't matter because anything divided by 1 is going to stay the same. All right, and there's your homework, and we will talk about that tomorrow.